Today we are going to discuss about force. Surely this word is not new to you. We all use this word in our daily activities, maybe individually or in group. We perform in many actions while sitting, walking, moving, eating, lifting, playing, everywhere we require force, isn't it? Now, the different activities where force is applied. In the first picture, your dad is unable to start his car. He asks you to push it from back. In the second image, two girls are pushing each other. Next to that, two girls are pulling to each other. And in the last picture, a man is pulling a cow by a rope, and cow is also pulling men by the same rope. In all these activities, force is applied. So we can say that force is a push or a pull. Now the effects of a force. A force can increase or decrease in the speed or motion. Force can change the direction of a moving body. Force can change the shape or size of a body. Force can stop body at rest. Force can make body moving, isn't it? Let's see with examples to understand it. Now, in the first block, a boy tried to increase the motion of tire, or he can decrease the motion as well. Even he can change the direction with the help of stick, and with the stick a force he generate. Now in the other picture next to it, a block is there which is at rest or stationary. A man with the help of rope try to pull it. In the picture, second picture, a force can change the shape and size of an object. Your mother must be applying force every day to a lump of dough by pressing it down by her hands. Next to the picture, a rubber band is stretched, or even balloons can be squeezed only by applying force. Now, to understand it more better, we should understand the rest and motion part. A body is said to be at rest if its position does not change with respect to a fixed point in its surrounding. Example, a book lying on the table, a bench fixed in a park. Motion. A body is said to be in motion if its position continuously changes with respect to its surrounding changes with time. A flying bird, a boy playing football. Note, the state of rest and motion of the body is relative in nature, and a body can both at rest and in motion at the same time. To understand this line with a common example, you are traveling with a school bus. From inside, when you look outside, you find everything is moving. Similarly, a person standing outside and watching your bus see you that your bus is moving. In both cases, you and the person standing are at rest, but at the same time, both you and the person outside of the bus are moving. This concept in physics is known as frame of reference. Now, in this picture, A and B is there. Now the A picture, a stationary object tends to move by applying force. A good example to understand is in cricket match. When a bowler holds a ball in his hand, the ball is at rest. When bowler bowls the ball, it starts moving. Here bowler apply force to do it. In the second image, a ruler or a scale is changing direction of a ball by applying force to it. To understand it, and take an example of cricket. When bowler bowls a ball to a batsman and batsmen apply a force through bat to hit it 4 or 6. It changes the direction of a ball by applying force to it. Now, the forces are of two types: contact and non-contact forces. Contact forces means the force which acts on a body by making an actual contact is called contact force. Non-contact force means the force which acts on body by no physical interaction or control. Contact forces. Muscular force. The force applied by muscle of a human or animal is called muscular force. Generally, we use this force to perform our daily activities like pushing and pulling. Mechanical force. The force applied by machine to make a body move. Frictional force. Force applied opposite direction to a moving object in contact is known as frictional force. Non-contact forces. Types are gravitational force, electrostatic force, and magnetic force. We will discuss each later. Alright. Now the examples of contact forces, muscular and mechanical. Look in the picture, the activities where muscular and mechanical forces are applied. Pushing and pulling is done by muscular force. And next to the picture, big wind turbines are there which convert heavy winds into electrical energy, or even the sailing boat uses the heavy winds to move in sea. Other forces. They are also very important, which sometimes are recognized by us. In the image you see a book lying on table. Surely every objects tend to drop downward due to gravitational force. Now here the book is at rest and showing an arrow downward, which means the force of gravity. And to encounter such force, there is opposite force applied in upward direction, and this force try to balance the object and makes the object at rest. And this force, we say it as normal force or reaction force. Even in our earth, the center part is carrying a centrifugal force, and to encounter this, a normal force is applied which is opposite to it. We say it as centripetal force of the earth. Remember, the normal force is applied to all the objects which are at rest. Now the next picture shows a tension force. It is a force which is applied by rope, string, cable, chain, wire, which acts against the force of gravity. Even the figure will be clearly stating that the iron ball is hanging with the help of string only. What is friction? When a body slides or tends to slide on a surface on which it is resting. A resting force opposes the motion is produced at a contact surface. This resting force is called friction or frictional force. It is a type of contact force only. Now here a blue block is applied force with a big red arrow on a green surface. The block gets frictional force which is against the motion. Here friction force is of three types. Static friction. Here frictional force and applied force is same. So the body is at rest, no motion. Here in a sliding friction, applied force is more than the frictional force. With the same way for the rolling, so the body is moving. Now each one we will discuss. First, static friction. The definition is the friction that occurs when objects are not moving. It is the friction that keeps the object in place. Example, a box sitting in the ground, your book sitting on table, your backside against the chair. Sliding friction. Definition: the friction that occurs when two solid objects move against each other or one object moves over another. Bicycle brakes, skinning your knees, walking, writing, and this, the image which is there, you must have used a slider to slide, isn't it? Rolling friction. Definition: the friction that occurs when an object rolls across a surface. Easier to overcome than sliding friction, which means that the sliding friction is more than the rolling friction. Example: anything with wheels, car, skateboard, or a ball rolling. Now here on the top, a piece of a block is kept on a surface where its force is downward direction, Fg, the force of gravity. To overcome Fg, and normal force is applied, which is opposite to it. Now, while pushing, a force is generated denoted as a capital F, and to oppose the motion, frictional force is applied, represented as small f. Now, even after applied force, the body is not moving and it's at rest. We say it static friction and represent as small fs. In other words, static friction adjusts itself with the applied force and cancel each other up to a certain limit. For example, if applied force, that is capital F, is 10 Newton, then static friction adjusts and apply a force equal to it, which we can say is that small fs is equals to 10 Newton, which results the net force, that is 10 Newton minus 10 Newton, that is 0. In other words, we can say that an object is at a rest. Now look, in the blocks which I made it, capital F is equals to small fs, means static friction. Means that the force which you applied is equals to the static friction. Or if the applied force is less than also to the static friction, the object will be at rest only. So from that we can make equation 1, that applied force is less than static friction. Now we will discuss about kinetic friction. It is the friction which apply on a moving object, or we can say that if applied force, that is capital F, is more or greater on an object, it tends to move towards the direction of applied force, that is capital F. In that process, static friction converts into kinetic friction because the friction will be there against the motion. For example, to understand better, if applied force, that is capital F, is 10 Newton and kinetic friction generates only 6 Newton force, then we can say here that big F is greater than kinetic friction, which states that an object moves the direction of applied force. In the block you can see that capital F is greater than kinetic friction, Fk. Take this equation number 2. Taking both the equation 1 and 2, one equation states that the applied force is less than the static friction. Another equation states that applied force is greater than the kinetic friction. Alright, now here we can understand by that static friction is greater than force applied, and force applied is greater than the kinetic friction. Alright, so from this we can understand that the static friction is greater than the kinetic friction. Kinetic friction consists of two frictions, that is sliding and rolling friction. So both frictions are smaller than static friction. Let's discuss the comparison between the sliding and the rolling friction with an activity for better understanding. Watch the picture above. A wooden block is resting on a table from hook of wooden block. A string is attached passing from the pulley and connected to pan which contains weight in it. Alright, now for sliding friction, try to increase the weight in the pan in such a manner that the block moves in a constant speed. Equal distance at equal interval of time, and record the weight W1 on the pan. Now rolling friction. Now remove all the weights from the pan and place two rollers below the block on the table. Again gradually increase the weights on the pan till the roller with the block begins to roll on the table, and record the weight WT on the pan. By comparing two weights, you will notice that W1 is greater than W2. Sliding friction is greater than rolling friction. We can get from this, which means that sliding friction needs more force to move against it as compared to the rolling friction. Now, here the old man tried to slide the box, which was difficult for him, so he applied a roller just under the box, and look a smile on his face, because now his applied force is less to move the particular box. Factors that affect friction. Roughness of the surface. The more rough the surface, the more will be the friction, because because rough surface gives better grip on each other. The extent to which the two surfaces press together. If the weight of a moving body is more, then friction will also be more. Nature of the surface. Dry surface have more friction, while wet surface have less friction. Clear? Now look the surface. Smooth versus rough surface, and closer view of the two surfaces. Here, in this picture, a man is moving object on rough and smooth surface. Easy to move on smooth surface because friction is less, but need more applied force to move an object in rough surface. In the second image, a microscopic view of rough and smooth surface when in contact with an object. The rough surface tries to interlock an object, which makes it difficult to move and need more force. Similarly, look the view of smooth surface. Interlocking is negligible, which do not obstruct the object to move and therefore require less force to it. Now, effects of friction. Friction produces heat, friction causes wear and tear. These two we will discuss it in the next slide. If friction opposes motion, we have already studied thoroughly about it. Now you must be clear how friction opposes motion. Now friction produces heat. Friction is a contact force. Friction produces heat. Now the matchstick is the perfect example. Friction causes wear and tear. Look the shape of your tire. Not your tire, I mean the shape of the tire. Advantages and disadvantages. Friction plays an important role in our daily activities. It would be difficult to sit on chair without friction, or even brush our teeth using a toothbrush. Friction help in supporting a ladder inclined to a wall. Friction between a piece of rough metal and a flint produces spark, and these sparks ignite the gas in a lighter. Think about that if friction would not exist, surely the evolution of fire would not be there, and our mankind could never grow prosperously and be how we are today. Friction enables the mechanical belt in car engine and machines to turn engine part. This moves the vehicles and the machine. Now, friction helps to grow our transportation with minimum risk. We do not get accidents. It is so these are the advantages. Now let's discuss about the disadvantages of friction. Now, friction produces heat. For example, machine parts that move produces heat. This heat can damage certain parts of the machines if the machine is not carefully controlled. Friction opposes and slows down movements. For example, riding a bicycle up a slope or paddling a boat. Friction wears away materials. For example, friction wears out the sole of shoes and tires of the wheel. So, from all these merits and demerits, we can say that friction is a necessary evil for us. Method of increasing and decreasing friction. Look one side where how to increase the friction. Now we should take care to increase a rough and dry surface. Here in the tire or in shoe, the grooves are there which increases friction. On the other side of the image, oiling or lubrication or even using ball bearing can reduce friction. It can be also reduced by making surface smooth and body as streamlined or aerodynamic to encounter the fluid friction force. Fluid friction force can be air resistance force or water resistance force. Now, non-contact forces. Gravitational forces. Force with which Earth pulls everything towards itself. It is force of attraction between particles of matter. Example, ball thrown up returns back to earth due to gravitational force only. Newton saw apple falling from the tree and then he understood the idea why it is happening, what type of force it is, and it gives the name of this gravitational force. Now about non-contact forces. The first one is we have already discussed. Now the second one is electrostatic force. It is the force between two charged bodies at a distance either repel or attract each other. Now let's discuss one activity which is there on one side of the picture. Take a plastic straw and cut it into nearly 2 equal pieces. Suspend one of the piece from the edge of a table with the help of a piece of thread. Now hold the other piece of a straw in your hand and rub its free end with a sheet of paper. Bring the rubbed end of the straw near the suspended straw. Make sure that the two pieces do not touch each other. Next, rub the free end of the suspended piece of straw with a sheet of paper. Again, bring the piece of straw that was rubbed earlier with paper near the free end of the suspended straw. You will observe that a straw rubbed with paper attracts another straw, but repel it if it has only been rubbed with a sheet of paper. Alright, I hope this activity is clear. Now we will discuss about the magnetic force. It is a force between the poles of two magnets at a distance. Like poles repel and unlike poles attract. Now this one more activity. Take a pair of bar magnets. Place the longer side of one of the magnets over the three round shaped pencils or a wooden roller. Now bring one end of the other magnet near the end of the magnet placed on the roller. Make sure that the two magnets do not touch each other. Next, bring the another end of the magnet near the same end of the magnet placed on the roller. Note what happens to the magnet placed on the roller every time another magnet is brought near it. You will observe the attraction and repulsion between the two magnets. Alright? From both forces it is very clear that they can attract and repel, but the gravitational force only attract. Alright? Now, units of force. 1 kilogram force is the force due to the gravity on a mass of 1 kg. 1 kgf is equals to force due to gravity on mass of 1 kg, which is equals to mass of 1 kg into acceleration due to gravity, is g, represented meter per square second. Alright, since the average value of g is 9.8 meter per square second, the SI unit of force is Newton. 1 kgf is equals to 9.8 Newton. As if we have to convert into gram, we know it that 1 kg is equals to 1000 gram. So here 1 kgf is equals to 1000 gram force. Now force carry direction along the magnitude. And what is magnitude? You have already studied. Magnitude means the value obtained in it. Here in this example, a 9.8 Newton is the magnitude. And force is a vector quantity which contains magnitude along with the direction. Scalar quantities are those quantities which contains only the value and do not contain any direction. A scalar quantity can be mass. Here mass is a scalar quantity. Alright. Now the big arrow represents more force. Clear? Now the measuring force through spring balance. Now here look the diagram. You must be looking, the different markings are there, and the zero error which it is showing means that it is on the zero marking, that is 0 Newton. And when any metal bob is attached to the hook, the spring stretches, and from 0 it reaches to 40. So what will be the weight of this metal ball? It will be 40 minus 0, that is 40 Newton. Alright. And there is one more way to measure force, that is compression balance. Alright. Now in this picture, it is a tug war game. You must have played it before. Now two teams are holding the rope and pulling towards their direction. Both teams are pulling in opposite direction of one another. Alright. Now left side and right side have equal member, and they generate a total force of 300 Newton. That is, each member is generating a force of 100 Newton if we divide equally. Now since both sides the force is the same, which makes the resultant force be 0, or the net force obtained by an object is 0, which means 300 Newton minus 300 Newton, that is 0. So no movement you will find in their positions, they will be stationary. Alright. Now, in the below picture, one team generates more force, that is the total force is 400 Newton, and another team generate only total force of 300 Newton. One team is generating 400, another team is generating 300 Newton, which clearly states that the team having more force will drag towards the other team, and ultimately the team which generate more force will win. And here if you have to find the net force, that will be 400 Newton minus 300 Newton, it will be 100 Newton. Now the first one is the example of balanced force, and the last one is the example of unbalanced force. This force is also known as equilibrium, and unbalanced we say it as unequilibrium. Alright, I hope you must have understood it well. Thank you.